Okay, now let's take a look at the first question for set 1, which is in this question. You have been given a problem about an owner of a company, an owner of a shop that wants to restrict the customer entry to his shop, okay, into only 10 at a time. So for any of the problem, when the input and output is not given, it is important that first you define all your input and output, as well as label them and give them an address. And I've seen from a lot of the answer that you don't have this label, and it's confusing on the ladder diagram because you don't label anything. Okay, so let's just first we start labeling, okay, the input and output. So say the input is you have a start button, and then you have a stop button, and then you have obviously entry sensor, and then you have exit sensor. What else of the input? No more. Output is the solenoid, as well as the pilot lamp. Okay, the pilot lamp that says full, please wait. Okay, so each of these must be given a an address. So say start, stop, entry sensor, and exit sensor. Solenoid, for example, is 100.00 and full is 100.01. Okay, now that's, at least you have this table, and then you should list down the requirements. Okay, so requirement must be less than 10 people. The solenoid will be on. Okay, solenoid on means it is unlocked. Alright, if it is equals to 10, solenoid must go off, or it should be locked, and also pilot lamp should be on. Okay, so that is the requirement, and you should when you press the start button, you should initialize the register. So right now we can take a look at how the requirement that we have here will affect the programming, and we have also to make sure that we use all the input and output required by the problem. Okay, so right now I think immediately that we can see is that there is a start button and the need to initialize the register. Okay, so initializing the register means we are going to use a move block. Okay, a move block which we transfer value 0 into the register. Say the register that we choose is, for example, D0. Okay, so I will use this instruction to initialize the register. Okay, so the first thing that we can do in a program is that we do the first rung with a start button, and then typically we will have a stop button which will initialize the register. But we have to understand that initialization must always happen only once in a program cycle, because if we maintain the power, or if we give more than one processing cycle, then the value will keep on initializing inside the D0. So we don't want that to happen. We have to make sure that the register is initialized once with a differentiate bit. So what you can do, basically, this is just the way I program. You can do it differently. As long as it serves the purpose, it's fine. Okay. So say I want to connect with the internal register 1. So I put an address here. Start is 0.00, stop is 0.01, and internal register is 10.00. Okay, so you realize that I didn't put anything inside the output here for internal register, even the compare block or add block, because when we put input and output list, is always concerned with the external devices that we connect to the system. Okay, all right. So with consideration that this is the start is momentary contact, so I'll put a holding circuit here. Okay, and then this internal register basically will activate one differentiated bit. So I use a diffu, say 40.00. So now you can write it like this. Okay, so 40.00 will initialize the program, the register. So you will move 0 to D0. So you can see I use 3 rung basically to just simply initialize. Okay, here. Okay, this is important because right now we have to make sure it's just done once. And if I use an internal register, I have full control to stop the program by using the normally close here. So when I press here, I will basically remove power to internal register and the rest of the program. Okay, so now I have initialized. Then we have to take care of the entry and the exit, and because we know that if the right now we know the register is 0. Okay, so once people comes in, this will add up. Okay, so we can so remember, use the differentiate bit as an entry sensor. Okay, so entry sensor is we have put 0.02. Okay, so entry sensor should add something to register. So you can use add bit with D0 and 1 and store back in D0. Okay, you can also use because I just put a hint using a plus. Okay, you can also use an increment block, which is plus plus D0. Okay, so this will be shorter, but any of this answer is correct. Okay, so just put the plus one here just to be consistent with the requirement. Okay, with the hint, not the requirement. Okay, now the exit also should be momentary button and momentary contact, and we have labeled. That's why it's very important to be consistent with labeling, okay, so that I know what happened. So exit sensor will be connected to the subtraction of the register. Okay, all right, so now we have both entry and exit. So right now we want to make sure that we have the requirement in place. Okay, we know that we have to check for whether the register is the value inside register is equal or not, or less than equal to 0. So what we can do is we can straight away do a comparison here. So CMP D0 with 10. Okay, so what it will affect, okay, the comparison block will basically affect the flags. Okay, so if we have P underscore less than, okay, connected to a solenoid, and remember the solenoid that previously is 100.00. So solenoid 100.00. Okay, so we know that as long as the register itself is less than 0, the solenoid will be on, okay, or it will be unlocked. If it is equal, okay, then the solenoid must be off lah, okay. Of course, when it's equal, then the less than flag will be off, okay, and then it should light up the pilot lamp full, okay. So some of you use P greater than equal, or P equal or P greater than equal. Both of that will be fine, okay. So because it will light up when the equal comparison is done, is achieved, okay. So if we look back at the input, we should make sure that we have a start, stop, entry, and exit sensor, solenoid, and lamp. And if we check here, we have we have here start, stop, okay, and we have the solenoid and full light here, entry and exit sensor. So all of the requirements here are fulfilled, okay. So this is how we answer the first part of the question. So the idea is that as long as you do some steps to initialize the register and do the plus and minus, doesn't matter whether it's increment or decrement or plus and minus, and do the comparison with number 10, then the corresponding flag is connected to the solenoid and the full lamp, then it's going to be fine, okay.